Welcome to today's lesson where we're going to be looking at current, charge and energy. So the learning intention for today is for you to be able to define common terms in electricity and perform calculations. In fact, calculations are going to be very important in today's lesson. The success criteria, you should know two formulae. You'll have learnt these earlier in the term and you should recognise these and you need to be able to use them. So the first of these is E equals Q times V. Energy is charge times potential difference. And the second is Q equals I times T, or charge is current times time. Looking at the more difficult success criteria, you should be able to explain the link between the potential difference, the charge and the amount of energy transferred. You should be able to explain volts in terms of units of energy and charge, so a potential difference of 1 joule per coulomb. You should be able to recall and use that equation, E equals Q times V, energy transferred equals charge times potential difference. You should be able to explain the link between electric current and electric charge, and know that electric current in metals is measured in terms of electrons, or talked about in terms of electrons. And you should be able to recall and use the equation to calculate charge, current, all the time the current flows. It's that Q equals I times T again, and being able to use that in different ways. The highest level success criteria, being able to combine E equals QV and Q equals IT, we won't actually do too much of because you're learning at home, but ask your teacher about it when you get back to school. In terms of vocabulary, we'll be using the word charge. So a charged object is something that has either a positive or a negative charge. It's a fundamental property of matter. You have come across it before. Protons have got a positive charge, electrons have got a negative charge, and that'll be quite important. Charge is measured in coulombs, which is given the symbol capital C, so that's quite an important term to be able to use and understand. And the last thing is the rate, how quickly something is happening. So how much of something happens per second. You might have come across it in chemistry. If not yet, you will do at some point. But speed is a rate, how fast you move, the distance you travel per second. The challenge task, we've talked about the two equations, and this links to the highest level success criteria. Could you combine the equations to define potential difference in terms of energy, current and time? So let's start actually by talking about current and charge. So an electric current is just the rate of flow of charge, how quickly charge is moving around a circuit. Think about the current of water, how fast water is flowing. It's much the same sort of thing. In metals, which is what we'll mostly be worrying about, current is the flow of electrons. Electrons are the charged particles, remember, that are able to move in a metal. A metal is a lattice of positively charged ions surrounded by a sea of delocalized electrons. Those electrons are able to flow and move. So if current is the rate of flow of charge, it's the amount of charge that moves in a given time, or current is charge divided by time. We really want to make charge the subject, so we need to get rid of this time at the bottom. If we're dividing by time, then to get rid of it we need to do the opposite, so we need to multiply by time. So multiply both sides by time. Current times time equals charge divided by time times time. Well, on the right hand side there we can cancel those two out and we end up with our final equation if we swap the two sides. Charge is current times time. So we've already mentioned charge is measured in coulombs, which is given the symbol capital C. Current is measured in amps, which has got the symbol capital A. Time is measured in seconds, capital S. And as we've done before, we can actually write this shorter. We don't want to be necessarily writing out the full charge equals current times time every time we're doing an exam question. So to make it quicker, we use symbols to represent each of the words. So charge is actually represented by the letter Q, and current, we've seen before, is represented by the letter I. Time is represented by the letter T. So charge equals current times time can be written much more quickly as Q equals IT. So the first task that you've got is to do some practice questions in task 3.1. I'm going to run through the first couple of these. If you're happy doing these, then you can skip this bit, but you do want to come back to the video because there's some more explanation later on. If you're not happy, then watch as I work through these questions. So here is task 3.1, and it starts with a table with 5 missing values, A, B, C, D and E, and I'll run through the first 3 of those and then leave you to get on with it yourselves. So number 1 asks you to find these values, so let's move across so I can write. Now my handwriting is bad at the best of times, and using this tablet it is even worse, so hopefully you can see what I'm doing. So for 1A, it's asking us to find the charge, so we don't know the value of the charge. If we don't know the value of something, we use its symbol instead, so I'm just going to write charge equals Q. We're given the value for the current, and that's 3 amps. And we are also given the value for the time, and that is 60 seconds. Now, when you're doing a question like this in an exam, you want to try and do this. You want to lay out the things you know and the things you don't know, because then it's really clear to you which equation you're going to use. Now, obviously, we know we're going to be using charge equals current times time, but if we didn't, we've written out all the things we know and all the things we need to know, quite quickly we'd see that that was the equation we want to use. In your exam, you want to write out the equation. You'll often get a mark for that. So charge equals current times time. And then what you do is you insert the numbers that you know. So I don't know charge, so I'm just going to insert the symbol Q. I do know the current is 3 amps. I do know the time is 60 seconds. If you're given the time in minutes or hours, you're going to need to change it. But for this one, 60 seconds, we know the values. And now I can very quickly work this out. 3 times 60 is 180. And the last thing I'm going to do is I'm going to put the units on. Q is measured in coulombs. Charge is measured in coulombs. So there we go. My answer is 180 coulombs. That one's fairly easy. Now, if I look at the second one in the table, slightly more difficult. I'm going to have to change the subject of the equation. So that's going to be slightly harder, but we can do that. So for 1B, this time the charge is equal to 1,250 coulombs. The current is the thing I don't know, so I'm going to use the symbol I, and the time this time is 100 seconds. Okay, again I'm going to write out the formula. This time I'm just going to write the short version. Q equals IT. So Q is 1,250. I, we don't know, so we leave the symbol. And T is 100 seconds. I'm going to need to change the subject to make I the subject. So I'm multiplying by 100 here. So the opposite of multiplying is dividing by 100. And I'm going to do that on both sides. I can cancel through these hundreds, and I end up with I equals 1,250 divided by 100, which is 12.5 amps. Okay. Last one that I'm going to run through is one part C. 3,600 coulombs for the charge, 5 amps for the current, and this time I'm being asked to find the time. So back I go, and this time I'm not going to even write out the whole words. I'm just going to go straight for Q equals 3,600. My charge is 3,600 coulombs. My current is 5 amps, and T is what I'm trying to find, so I'm just going to leave it as T. Q equals IT. 3,600 equals 5 times T. Again, I need to change the subject. I'm multiplying by 5 here, so I'm going to divide by 5 on both sides. And then I'm going to rewrite it, so T is 3,600 divided by 5, and it's perfectly alright to use a calculator for this because you are not expected to know it yourself. I'm going to quickly double check my working, and my answer is 720 seconds. Oh, let's try and 720 seconds. Now carry on and do the rest of these yourself. Remember, if you've got a time in hours, you're going to need to convert it into seconds, and I will leave that up to you. So hopefully you've done all of those questions for Q equals I times T now, and now we're going to look at charge and energy. So if we've got a simple circuit, the cell is a store of chemical energy, and that energy can be transferred to the charges in the circuit, which for metal wires is going to be electrons. So the energy is transferred to the charge, and the charges are able to move around the circuit. These charges have got potential energy. They can now transfer energy to the components in the circuit. So as they continue to move around the circuit, when they reach a component, they can transfer energy to it. In the case of this lamp, energy is going to be transferred from the charge as it moves through the lamp, and the lamp is then going to transfer the energy to the surroundings by heating and by light. The charge itself, the electron, will continue to move around the circuit. When it reaches the cell, it will be more energy will be transferred to it again. It will carry on travelling around the circuit. So our cell is a store of chemical energy, and the charges can carry that energy around the circuit to be transferred to the components. If we think about it, what that actually means is that potential difference in the cell is the energy transferred per unit charge, and this is a definition you need to remember. What that also means is that 1 volt is 1 joule per coulomb. So these are 2 really important things that you need to remember. In terms of another equation, potential difference is the energy transferred divided by the charge moved. And again, we normally use this in a slightly different way. We make energy transferred the subject, so we need to get rid of this charge moved. We're dividing by charge moved here, so to get rid of it we need to multiply both sides by charge moved. So now we get this, and on the right hand side here we can cancel out the charge moved, so they cancel each other out. We can swap over the 2 sides to have energy transferred on the left hand side and charge moved times potential difference on the right hand side. That gives us our final formula. Energy transferred is charge moved times potential difference. Energy, we should be familiar with by now, is measured in joules. That's got the symbol capital J. Charge, we've already said this lesson, is measured in coulombs. That's capital C. And potential difference, we know, is measured in volts. That's capital V. If we don't want to write out the full formula, and this one's particularly wordy because we've got to use energy transferred, charge moved and potential difference, then we can write it shorter by representing energy transferred with the symbol E. charge moved with the symbol Q, and potential difference with the charge V, with the symbol V. So E equals QV. So you've got another task to do now, some more questions to carry out. Have a go at those. Again, if you stay with the video, I will run through the first couple of practice questions to help you. Otherwise, you can skip ahead a bit. So the questions for task 3.2, the E equals QV, this is much the same as the ones for Q equals IT, so hopefully you can see that much of it's going to be exactly the same. We're going to write down the things we know and the things we don't know, write the formula, the equation, put in the numbers that we know, and then do any calculations that we need to. I'm going to again just do the first couple of these in the table, and I'm also going to quickly talk about the next question as well, because there's some information in there that you might find more difficult. So question 4 part A is for the AA alkaline long life battery. Let's quickly bring that, put that onto here. So 4A, I know my energy is the thing I'm trying to find, so I'm going to give it capital letter E. I'm given the charge, which is 7,600 coulombs, and I'm given the potential difference, and it's really struggling with this pen. Potential difference is 1.5 volts. And so I'm going to write my formula. Energy is charge times potential difference. Energy I don't know, so I'm going to write it as an E. Charge is 7,600 and the potential difference is 1.5, and then I'm going to work that out as 11,400, and remember my units are joules. Good, let's look at B part B, which is a lithium camera battery. This time I'm given the energy and the charge, and I'm asked to find the potential difference. So for 4 part B, the energy is equal to 1,350 joules. The charge is equal to 450 coulombs, and the potential difference we don't know, we're going to leave it as a B. Our formula, E equals QV, 1,350 equals 450 times V. I need to get rid of this 450 on this side, so I'm going to divide both sides by 450. They cancel. That gives me V equals 1,350 divided by 450, which is 3, and the units are volts. Good. I'll let you do the rest of those yourselves, but what I am just going to do is I'm just going to move on to this question, and something to watch out for here. The student has a power bank external battery pack for his phone. The charge is given in units of milliamp hours. Now don't worry too much about that, because the question is going to take you through it, but the one thing you might be struggling with is the idea of a milliamp. A milliamp, I don't know why that didn't go in red when it should have done. A milliamp is an 1,000th of an amp, or if you're familiar with standard form, it's 1 times 10 to the minus 3 amps. So when you're asked to put in your value for milliamps for the current, you're going to write in 1,000th of an amp. 6,000 milliamp hours would be 6,000th of an amp for 1 hour, and that's what you're working out here. All right, finish off those questions and then that's you done for the day.